Hi guys, here we are for skill 2.6. And 2.6 focuses all on explaining angle measure, everyone's favorite thing to do. So your essential question for today is how can I use what I know about angles to explain my reasoning? And over the past couple of years, we've seen a recent trend in the exams where they're asking students to more and more frequently explain their responses. So it's really important that you can not only figure out what questions are looking for, but also explain how you got there and essentially your understanding of the material. So we're going to go through a couple examples here, and hopefully you already know by seeing the word explain, we're definitely going to do some writing. So bear with my handwriting here. Hopefully it's getting a little bit better each time. So example 1, it says, given the diagram below, explain why the value of angle 1 is 56 degrees. So they're telling us that angle 1 is 56, which is right over here. And we just got to figure out how they get there and explain our process each step along the way. So first thing I might look at is they gave me one angle measure already, 56 up top, and that 56 lives in this big triangle that I have here. All right? And within that triangle, it's telling me that these two sides are congruent. So that must mean that triangle ABC is going to be isosceles because it has two congruent sides. And we know that triangles that have two congruent sides also then have two congruent angles, one of which is going to be this angle down here. You might be saying, well, Miss Wesley, isn't angle 1 the other congruent angle? But it's not, because angle 1 is only part of that congruent angle. So we're going to find this angle, but it's not going to be our answer. So the first thing we're going to have to do is we're going to figure out, well, what is that missing angle, or essentially what's angle C? And how we'd go about this is the first thing we know is that triangles have to add up to 180. So I'm going to do 180, take away that 56 from my vertex angle, and in doing so, I'm going to be left with 124 degrees. Now, remember, that means that this angle is not 124. It means that this angle on the left and this angle on the right together have to give me 124. So the next thing I'm going to have to do is take 124, divide it by 2, and when I do that, I'm going to get 62 degrees. So that's going to make this angle down here 62 degrees. So I didn't know that before, so that's something we need to write down in a sentence. So we can call that angle C because there's no other angle C in our picture, it's the only one. So first thing, the measure of angle C equals 62 degrees since triangle, I'm going to name that orange triangle I outlined, ABC is isosceles and isosceles triangles have two congruent sides and angles. All right. So we figured something out, but it's not angle 1 yet. So our goal is still to figure out what angle 1 is. We know it's going to be 56, we just have to get there. So the next thing I'm going to look at is we actually have this other triangle within our picture. This triangle right here. All right. And also notice that we have another set of congruent sides. I want to get a different color here. It says AC, these two little marks, and AD are congruent. So this is another isosceles triangle. It's just turned. So if you notice, this angle C that we just found is going to be congruent to this angle over here. Again, because it's an isosceles triangle, and isosceles triangles have two congruent sides and two congruent angles. So not only is that one angle 62 degrees, but that would force this angle over here to also be 62 degrees. So again, we didn't know that, so we have to jot that down as our next sentence. I'm going to call that angle ADC. If you call it CDA, that's also fine. So the measure, where's my M? The measure of angle ADC equals 62. since, and we're essentially going to write the same exact sentence we wrote up above. We're just going to change the name of the triangle. This time we're talking about triangle ADC is, alright. Oh, sorry if you guys just saw something weird. My screen just went crazy. ADC is 62 since triangle ADC is isosceles and has two congruent sides and angles. All right. I took out the second word isosceles triangles just to save myself some room. So we now know two of those angles in the green triangle, and that's really helpful because now we can find angle 1 using the fact that angles in a triangle have to add to 180 degrees. So the last little bit of work that we'd have to do is take 180 and subtract away that 62 and the other 62. And in doing so, we will figure out that we'll also get 56 like the problem says for angle 1. Now remember, if you're doing a problem like this where it tells you what your answer should come out to be like this, and you don't get the same answer as what it says, please go back and check your math. You might have just typed something in wrong or happened to write down the wrong number. So we officially proved it's 56. We just have to write one final sentence here. So we can say the measure of angle 1 equals 56. And again, hopefully you're thinking that your reasoning here as I'm about to write down. Since angles in a triangle add to 180 degrees. And that was our final sentence, our final conclusion. So this problem really focused on knowing your isosceles triangles and recognizing that we have a triangle within another triangle, and the idea that triangles always add to 180 degrees every single time, no matter what kind of triangle you have. Now, we're going to jump down here and look at example 2. So it's given the diagram below, determine the value of angle 3 and explain your response. So, notice the first thing I see here are these little arrows. All right, remember the arrows mean parallel. P-A-R-A-L-L-E-L. That should be an A. There we go. So that means I have parallel lines. And thinking back to one of the earlier skills, when you have parallel lines, something you want to look for right away are alternate interior angles. So this angle C down here is 44. But because my lines are parallel, that's also going to make angle A be 44. And again, we didn't know that before, so we're going to make that be our first piece of information that we jot down. So the measure of angle A equals 44. Since lines are parallel, we can actually be specific here, since AB is parallel to CD, alternate interior angles are congruent. Alright? Now remember, you can't just say angle A is 44 since lines are parallel, and you can't just say angle A is 44 since alternate interior angles are congruent. You have to have both pieces of information there to get full credit. So our goal here is to find the measure of angle 3 right here. But before I do that, I'm going to look at the fact that I have this triangle here. Alright? And there's actually two ways you could go about this problem right now. The one that a lot of you might be thinking is, oh, I have a triangle, so we can actually go ahead and find the missing angle right here, because we know angles in a triangle have to add up to 180, and that's perfectly correct. So off to the side, we can take 180 minus the 44 minus that 37, and in doing so, we're going to be left with 81 degrees. So this angle on the inside of our green triangle here is 81 degrees. Now again, that's something we did not know before, so that has to be our next sentence that we jot down. So we're going to say, I'm going to call that angle AEB. If you want to call it BEA, that's fine. So the measure of angle AEB equals 81 cents. Should be any angles in a triangle equal 180. And now we're just one step away, because if you notice, angle 3 and the 81 that we just figured out make a straight line, and we know angles in a straight line also have to add to 180. So the last thing we'd have to do is 180, hopefully you can still see that, take away the 81, and in doing so we will be left with 99 degrees. So that means angle 3 is 99 degrees, and we just have to explain ourselves one last time. So the measure of angle, what was it, 3? Equals 99 since angles on a line equal 180. All right. So that question there again used the fact that the picture, everything was given to us, and we had to recognize parallel lines to get alternate interior angles. We used the fact that angles in a triangle add to 180, and then we used our supplementary property that says two angles on a straight line also add to 180. So take a minute, go back, copy anything down that you might have missed, re-listen to anything that you need to, and we have another example on the next page we're going to take a look at. Okay, so here we are, one final example, example 3, and it says, given the diagram below with one pair of parallel lines, and again we can see that they're parallel based on these arrows, determine the value of angles A through D, explain your reasoning for each angle measure. So each time we find a missing angle, we have to explain or back up our reasoning. Now, you could actually start by finding a couple different angles here. For instance, you could find angle D right away. You could find angle B, C, or A. Any of them you could actually find first. I'm just going to go in alphabetical order here. If you think you want to go ahead and find the other angles and then pause the video and then come back and play it to see if you're right, go for it. I'm not going to stop you. Because that would actually be a really good thing to try. But if you want to just walk through it here with me, I'm going to go ahead and start by finding angle A. So angle A is down here. And it told me that there were parallel lines. So anytime you think or hear parallel lines, you want to think alternate interior angles. And remember, in finding alternate interior angles, you look for the Z. So notice I have a Z right there. So within that Z, I'm going to get alternate interior angles. So A is actually 58 degrees since lines are parallel and alternate interior angles are congruent. So that's going to be our first sentence. So the measure of angle A equals 58 degrees since lines are parallel and alternate interior angles are congruent. All right, so we got one of the four angles down. Now we're off to find angle B. Again, I'm just working in order here. Well, angle B is over here. All right. And I still have parallel lines, so I actually can get another Z out of this. It's a backwards Z. So in doing so, angle B is 48 for the same exact reason that we wrote up above. So my next sentence is going to be essentially to copy that. It's just going to be angle B and 48 instead of A and 58. So, see, I'll write in red, probably easier to see. The measure of angle B equals 48 degrees since lines are parallel and alternate interior angles are congruent. Okay? So we found A, we found B. There's two ways right now you could go about finding C. One of them could be the fact that you're noticing A, B, and C are all in a straight line, so they have to add up to 180. You could do that. Or you might be noticing that we have a triangle here. So all three of those angles also have to add to 180. And they're going to get you the same answer because both of those properties are going to force C to be the same thing. So no matter which way you're thinking about this, whether you're thinking the straight line or you're thinking the triangle, you have to do the same math to figure out what C is. So off to the side here, either way we're looking at this, we have to do 180, take away the 48, take away the 58, and we're going to get 74 degrees. All right. So I'm going to write my explanation using the fact that angles in a triangle have to add to 180. But remember, you could write the same exact thing and say because angles in a straight line have to add to 180. Either one of those will be correct. It's whatever one your brain went to first. So the measure of angle C equals 74 since angles in a triangle equal 180. All right. So now all that's left to find is angle D. Angle D is way over here. Well, in this scenario, I'm going to look at the fact that 58 and angle D are on a straight line, and we know angles on a straight line have to add to 180. So 180 minus 58, that's going to leave me with 122. So our fourth and final angle here, the measure of angle D, is 122, since angles on a straight line equal 180 degrees. All right. So hopefully this last question here kind of summed up a lot of the stuff that we've talked about so far, especially explaining your responses. If any of these steps did not make sense along the way, or if you were thinking about going about the problem a different strategy or a different way, please let your teacher know so we can just check that strategy to make sure it was correct, because a lot of these problems do have multiple approaches to them. But remember, anytime you see those wonderful words explained that everyone loves so much, you have to write complete sentences for each step in the process. So look these over, try those blue practice problems, and then write yourself a summary talking about how you write a good explanation, and then when you're ready, take that CFU, and you're almost done with Unit 2. See you next time in Unit 3.